Okay, next we're going to take a look at volumes of pyramids and cones. So again, just a quick reminder, we are doing basically the volume is what's inside, all right? And for the volume of a pyramid, we are going to take the area of the base times the height. Okay, so it looks kind of like a prism, but we're going to divide that by 3. What that means is if I took this pyramid, if I took 3 of these and I put it into a prism that had the same base and the same height, I would be able to fit 3 of those pyramids. For volume of a cone, same thing. I can fit 3 cones of this size into a cylinder that has the same base and the same height. Okay, so area of the base times the height divided by 3. Remember, the base is always pi r squared, so if you want to just remember, volume for a cone is pi r squared times the height divided by 3. Now, another quick reminder, we are not using slant height for volume. We are using the altitude, the height that goes right through the center of our pyramid or cone, versus the slant height. Remember, slant height was on the outside. Okay, let's find the volume. We'll round to the nearest hundredth. So here, the 7 feet is referring to the height, so I can just kind of plug this in. So it's area of the base, so that's going to be pi r squared, so 3 squared, times the height. And then don't forget, we got to divide by 3 for the cone. So that will be, if I were writing this in exact form, it would be 21 pi, but we're going to round to the 100th place. And I get 65.97. Again, we're still working with cubic units. Okay. All right, volume for the next one, it's a pyramid. Now, this is not a square base. If you notice, we have a 16 and a 10, so it's actually a rectangular base. So the area of the base in this case is going to be 160. Okay? And so the volume is going to be 160 times the height, which we see there is 12. And then we're going to divide that by 3. So 160 times 12 divided by 3 gives us 640 cubic inches. All right, with C, they give us this angle is 60 degrees, so we have a 30, 60, 90, and we need to do special right triangles to figure out the radius. So if 12 is opposite the 30-degree angle, right, and this is pointing to 60, I want to take 12 and divide it by root 3. So that's going to actually give us 4 root 3 for the radius. Now when we do the volume, okay, so we're going to have pi times 4 root 3 squared times the height, which is 12, and then that's all divided by 3. So let's see, well, we wanted to write this in exact form, it would be 192 pi. And since we're rounding to the 100th place, we get 603.19 cubic millimeters. Okay. D, so this is a pentagonal prism. So I see that the base is a pentagon and each side is 6 centimeters. Okay, so we go way back to finding the central angle, right? 360 divided by 5 is 72. We're going to cut that in half and draw here. So this will be 36. This part is 3, and I need to find the apothem. So in order to find the apothem, I'm going to have to use tangent. So tangent of 36 equals 3 over a. So the apothem is 3 divided by tangent of 36. So we'll do that on our calculators. And I get the apothem is 4.13. Now, to find the area of that base, I also need to know the perimeter. So that's going to be 6 times 5, which is 30. So the area of the base is going to be the perimeter times the apothem divided by 2. So 30 times 4.13 divided by 2 is 61.95. So for the volume, right, it's going to be area of the base times the height divided by 3. So our area of the base, 61.95, times the height, which they give us here is 10, and we want to divide that by 3. And I get about 206.5, and that's cubic centimeters.